Hello. Can you hear me?
Yes, good morning, Mr. Lee Sang-il.
Good morning.
Yeah. Good morning.
Good morning. Can you hear us as well?
Yeah. Thank you very
How
much.
are you doing?
Yeah, invite me.
No, thank you so much. Thank you so much for willing to participate in this focus group discussion.
Yeah. So yeah, I okay. Thank you very much. Invite me also. And I think the first seminar.
Yes.
About detail about the MMR project. So today, I understand that the title of today's seminar is related to the nuclear fuel cycle, radioactive waste management, something like that. That's correct?
Yeah. Yes.
Okay.
Yes.
Okay.
Yeah.
Thank you.
We are from the Research Center of Nuclear Fuel Cycle and Radioactive Waste Technology.
Okay.
So I think in the past, maybe a few months ago, I also attended your presentation, your webinar with Mr. Jarrod, I think.
Yeah.
On the reactor.
Yeah, the reactor technology also.
Yes, on the reactor technology.
Demonstration project.
Yes. So for us, it will be very interesting if we could also learn about the fuel cycle and radioactive waste management of the MMR.
Okay.
So I see that besides you, there's also Mr. Young Jae Choi.
Yeah, Young Jae Choi sent the presented material.
Yes.
Yes. Also, I today seminar myself so often present material for explain material to and Indonesia the plant nuclear plant.
Okay. So
now, okay.
Yes. No. Go ahead, please.
Yeah. So after everybody participation, so I will open the printed material myself.
Okay.
Thank you.
So for the agenda, we will start with Mr. Saiful Bakri because Mr. Rohadi Awaludin has another engagement. I think he has a parallel engagement. And then your presentation. Do you know how long will your presentation be? I mean, 30 minutes, 45 minutes? I mean, we're open.
Yeah. So, and I do not explain the Jarrod.
Yes.
Dr. Jarrod. Yeah, Dr. Jarrod told me it's good 40 minutes, about 40 minutes.
Okay, that sounds good. It's up to you. I mean, we're
okay. Thank you.
Because there's only one presentation from you, and then we go to the discussion.
Okay.
Question and answer, and yeah, I think that's the plan for today.
Good.
So you have like a full 2 hours. I mean, are you free for the next 2 hours?
No problem.
Okay, good. Just to make sure. And we plan to finish at 11 local time.
Mm-hmm.
So it's a 2 hours focus group discussions, maybe earlier. It depends on the questions and answers, but that's the plan. Yes.
Okay, thank you.
I will check with the Google. What time is it in Korea right now?
It's 10:54.
Okay. So it's just perfect for lunchtime.
Normally the lunch is 12. Yeah, 12.
Yes.
Yeah, the 12 to the 1 p.m.
Okay. Okay, so it's 2 hours, yes. Okay, that's good. We're still waiting for more participants. Okay, Pak Jarod, welcome Pak Jarod. I think you're still muted. Oh, okay. Okay,
Hello.
no problem. Still in the car, okay. Yeah, no problem. Okay. So the project actually has started. Yes. I saw the slides, the presentation slides.
Okay. What? Yeah. What?
Yeah,
Please,
the MMR project in
yeah,
in Chok
already
River
start.
already started this
Yeah.
year. Yeah.
No. So,
Hello.
yeah,
Good
hello.
Yeah.
Hi.
Halo Pak Jarod. Yeah.
Jarod. Yeah.
Yeah. How are you? Thank you for your time to discuss with us.
My pleasure.
Yeah.
Thanks, Pak Jarod. Thanks, Mr. Lee, as well.
Thank you.
Thanks for coming to our discussion. Hopefully, we can learn a lot of things, as well as perhaps can start some kind of collaboration after this.
Yeah. Hopefully, Pak Saiful.
Yes.
Yeah. I think the question of Miss Christina is very good, Dr. Sangil, about the progress of. Well, later on, maybe you can explain it to us.
Thank you.
Pak Saiful, we should start exactly at 9 or? Yeah.
We can start exactly in
At
9 o'clock, I think. Yeah.
Okay. Ini ada MC atau tidak atau langsung ya Pak? Soalnya saya ngeliat
Ada saya, Bu.
ada MC.
Ada Bu Anissa.
Siap. Sip.
Nice to meet you.
Nice to
Yeah.
meet you.
Miss Anissa will be the MC. Okay, that's good.
Moderator Bujo, and hopefully my signal here, the internet is quite good, hopefully, so I can listen completely.
Yeah, it's clear.
Completely.
Yeah.
Oh, it's clear, Pak Jarod, yeah. Oh,
Yeah.
thanks God.
Yeah.
This
Your
morning
voice
is good, I
is
think.
clear. So,
Yes.
because you are a very important person, you should participate in full time.
Thank you, Pak Jarod.
Oh. Ini kita mulai, Pak.
Ya, silakan, Mbak.
Bapak Ibu dimohon untuk mematikan mikrofonnya ya. Bismillahirrahmanirrahim. Ladies and gentlemen, please be sure to turn off your microphone as the agenda is about to begin. Thank you. The Honorable Head of Nuclear Business Office, Hyundai Engineering, Mr. Il, Chairman of Research Center for Nuclear Fuel Cycle and Radioactive Waste Technology, Dr. Saiful Bahri, Ms. Johanna Maria from the National Research and Innovation Agency, and all participants. Good morning and Assalamualaikum warahmatullahi wabarakatuh. Thank you for joining us today on this forum group discussion, High Temperature Reactor, Nuclear Fuel and Radioactive Waste Treatment Technology as a collaboration between the Research Center for Nuclear Fuel Cycle and Radioactive Waste Technology, BRIN, and Hyundai Engineering. My name is Anissa Isnaini, and I will be your MC today. Ladies and gentlemen, recently, Hyundai Engineering and Ultra Safe Nuclear Corporation signed a cooperation project design contract to construct a next-generation micro-modular reactor MMR and develop a multi-purpose higher temperature reactor MP-HTR. They will build a demo MMR generator in Chalk River, Canada that will be operating into 2026. Besides generating electricity, this multi-purpose MMR is also expected to produce hydrogen. Today, we will discuss about the technology of HTR nuclear fuel and radioactive waste treatment. But before we start the agenda, at first we will sing the national anthem of Indonesia. Thank you. Move to the next agenda. We would like to invite the head of the Research Center for Nuclear Fuel Cycle and Radioactive Waste Technology, Dr. Saiful Bahri, to give an opening remarks and open this forum group discussion.
Thank you, Mbak Nisa. Can you hear my voice? Hopefully it's quite clear
Yes.
for today.
It's clear, sir.
Yeah, okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, distinguished head of Hyundai Engineering, Mr. Lee Sang-il, and distinguished participants today from Research Center of Nuclear Fuel Cycle and Radioactive Waste Technology, and also other colleagues from National Research and Innovation Agency, or BRINS. I would like to pass the apology from Dr. Rohadi Awaludin. He cannot attend for this morning opening remarks. He has another engagement today, and I would like to read his opening remarks for these events. First of all, I would like to thank Mr. Lee Sang-il, Head of Business Office, Hyundai Engineering, and I would like to thank also to everyone for joining this forum group discussions about HTGR and MMR. The introduction of net zero emissions policy by the Indonesian government in 2021, and also the roadmap released by Ministry of Energy and Mineral Resources, or ESDM, shows that nuclear energy is expected to contribute to energy mix supply about 5 until 7 gigawatts by 2049 and 35 gigawatts by 2060. And the Research Organization for Nuclear Energy, or ORTN, at the National Research and Innovation Agency, BRINS, has the task to conduct research and innovation in the field of nuclear energy. And we believe that global engagement and paving cooperation with the internal partners are necessary today to improve and leverage our capacity in research and development, and also to support the government program in net zero emissions. And we think that HTGR, high temperature gas-cooled reactors, especially our topic today, has the potential to revolutionize, make sort of revolution for nuclear power industry, because its compact size also has efficiency and ability to operate at higher temperature, and quite attractive to be option for the next generation, which provide clean and reliable energy and also heat for industry. Establishing such communication between BRIN and industry, and which also cooperation, particularly with the nuclear power plant vendor, such as today, has been the main challenge today. And the fact that Indonesia right now has not decided on which reactor to be deployed. Regardless, our nuclear agency needs to find a common ground that can be accepted by international partners. We need to increase the nuclear contribution to attract, and we still need to discuss the issue surrounding the fuel cycle and waste technology. And so we again really appreciate the Hyundai Engineering and Ultra Safe Nuclear Corporations in this forum group discussions, and I hope the webinar will be beneficial for all of us. And last but not least, I would like again thanks to the committee from the Research Center for Nuclear Fuel Cycle and Radioactive Waste Technology, and also the team for co-organizing this event with the Hyundai Engineering and Ultra Safe Nuclear Corporations. By say Bismillahirrahmanirrahim, I would like to declare that this forum group discussion or focus group discussion with the Hyundai Engineering Office and Ultra Safe Nuclear Corporation officially opens. That's all, I think. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Saiful Bahri. Ladies and gentlemen, after this opening ceremony, we will go directly to the main agenda. This session will be hosted by Ms. Johanna Maria as moderator. Ms. Johanna Maria, time is yours.
Thank you very much, Ms. Anissa. Ladies and gentlemen, we are honored today to have Mr. Lee Sang-il from Hyundai Engineering Company to give us a presentation on nuclear fuel cycle and radioactive waste management of MMR, micro-modular reactor, and HTGR, high temperature gas cooled reactor. Mr. Lee Sang-il was also here with us, in Indonesia, a few weeks ago or a few months ago, explaining about the reactor technology. So we are lucky today to have him deliver another presentation focusing on the nuclear fuel cycle and radioactive waste technology. Before we start, I would like to read his resume. Mr. Lee Sang-il is the chief engineer at Hyundai Engineering Company. Previously, he was working for KEPCO from 1997 to 2009. He was the senior safety analysis engineer, principal safety analysis engineer, and his last position at KEPCO was a technical project manager. From 2010 until today, he was with the Hyundai Engineering. He started as a deputy chief engineer and then chief engineer, and now he's a team leader. He graduated from the Seoul National University in nuclear engineering and got his master and PhD degree from KAIST. Mr. Lee Sang-il, I think we can start now. The time is yours. You have about 40 minutes for the presentation, and then after that, we will have questions from the participants. Please type your questions in the chat, and then I will help read the questions to Mr. Lee Sang-il. Go ahead, Mr. Lee Sang-il.
Okay, so I will share my presentation.
Okay, we can see it.
Okay. You can see? Okay.
Yes, okay. Yeah, it's good.
Okay.
You can start. Thank you.
Okay, thank you very much. My name is Sang-il Lee, already and introduce me by and Joanna, Dr. Joanna. So, and I am head of nuclear fusion office in Hyundai Engineering. Also, I was a project manager of develop of MMR since and 2015. So, and only this year, and Hyundai Engineering have had a contract, engineering and the procurement and contract with the USNC for a Choco River project. So, and I think last seminar topic is related about the MMR process itself. So today's topic about the nuclear fuel cycle and the radioactive waste management, MMR and HTGR. So today I am going to make a presentation generally. So I am a project manager. So I do not know in detail. However, I have many the experience about the nuclear project in the large light water reactor also, and HTGR, also MMR, also, and radioactive management, the project in Korea. So some I can explain briefly the general technologies. If you have more technical questions, please let me know. I will send by email the detailed the answer about your question. Okay. And I think in the introduction, I think you are the nuclear expert. So I'm going to explain briefly some introduction to HTGR, high temperature gas cool reactor. This slide showed the comparison between the pressurized water reactor and high temperature gas cool reactor. Is you know this left hand side is this PWR. Many this kind of PWR were built in Korea. This technology coming from the U.S. company we call the Combustion Engineering company. This is total power of this reactor is about 1400 megawatt electric. Some very big structure. Some PWR consists of reactor, and this is a steam generator in the reactor coolant pump and the pressurizer. However, high temperature gas cooled reactor, and this many so many systems, including in the just one and the reactor, the pressure vessel we call the integrated type, very simple design. Also, is the major difference between PWR and HTGR is about the technology of a reactor, like coolant, moderator, core outlet temperature, core pressure, and the fuel. I think the very important aspect of a high temperature gas cooled reactor is can produce the high temperature steam. This kind of high temperature steam is used for many industrial applications like hydrogen production, the chemical plant application, also electricity, also district heating and application. And the nuclear fuel, this is a normal, the nuclear fuel of PWR, and this is HTGR nuclear fuel. I will explain detailed and next slide. And yeah, this is show the history of HTGR. And HTGR high temperature gas cooled reactor. In the original technology is the not helium, is we call the CO2, carbon dioxide. From the 1950 in the UK, England, the built and the gas cooled reactor like Meganox and the Wagner. After that, from in the 1970, and German and the US, UK, and finished to develop about the high temperature gas cooled reactor using helium. And at that time, and all the designs, some concrete pressure vessel, and after 1990, many country started to develop more advanced high temperature gas cooled reactor. So HTTR HR10 is a kind of test or research reactor for high temperature gas cooled reactor. So after that, after 2010, many countries like Japan, US, South Africa, China, also Korea started to develop the more advanced HTGR. However, China HTR PM only finished to construction. So now, also, this is, I think this is old style, still the old style. So however, now 2022, 2023, some in US and more advanced the gas cooled like MMR and X energy. So I think from this slide, I brief introduction about the MMR Chalk River project. I think and some show the okay. So I think the showed some slide, some movie. Okay. Can you hear this voice?
Yes, we
Thank
can.
you. Thank you.
At every moment humanity is taking a leap, Hyundai Engineering is there. Hyundai Engineering has grown into a global engineering and construction company through successfully performing more than 5,000 projects worldwide. As a member of the Hyundai Motor Group, it continues its gleaming challenges based on the worldwide network of the group. Based on its capabilities, Hyundai Engineering is now transforming into a carbon-neutral energy company, carrying out projects for hydrogen production plants using waste plastics, clean hydrogen extraction using ammonia, and nuclear projects such as next-generation micro-modular reactors. The surface temperature of the Earth has increased since 1880, and it causes climate change. To prevent severe climate change, we need to reduce carbon dioxide emissions. About 44% of global carbon dioxide emissions comes from electricity and heat generation. To reduce carbon dioxide emission, the world introduced renewable energy and nuclear energy. However, renewable energy as the base load power could be limited by region due to its dependence on weather conditions. Therefore, we consider nuclear power for a stable supply of energy. Furthermore, we developed the fourth-generation nuclear power plant micro-modular reactor, which is safe and can be constructed anywhere. The MMR plant generates heat and electricity by using nuclear fission energy, and it does not produce carbon dioxide while operating. Fully ceramic microencapsulated fuel provides inherent safety even at high temperatures and eliminates the possibility of severe accidents. Additionally, it requires no refueling for its lifetime of 20 years. It is easy to transport and construct through modularization and can be constructed near chemical plants or cities because emergency planning zones are not applied. By utilizing high-temperature steam from MMR, it is possible to produce hydrogen and provide process heat to industrial plant. As the implementers of the project, GFP, Hyundai Engineering, and USNC are aiming to complete the first MMR project built at the site of Canada Nuclear Laboratory near Chalk River in Ontario, Canada. The reactor of MMR plant is a high-temperature gas-cooled reactor with a capacity of 5 megawatt electricity. The area of the Chalk River site is 2,400 square meters, and MMR plant consists of about 80 modules. The MMR plant area consists of the nuclear plant area and the adjacent plant area. In the nuclear plant area, there is the citadel hull, main control room, decontamination room, and auxiliary rooms. In Citadel Hull, there is a gas-cooled reactor with a 15 megawatt thermal capacity. In the adjacent plant area, there is the steam turbine building, molten salt system, steam generator, cooling tower, and other auxiliary rooms. There's a 7 megawatt capacity of turbine and turbine generator in the steam turbine building. The molten salt system has been adopted as a heat reservoir and it provides heat to the turbine. The steam generator consists of an economizer, evaporator, and superheater. By applying cooling tower, MMR can be constructed in remote areas where there are no seas, rivers, or lakes. The helium heated by nuclear fission energy in the reactor goes to the intermediate heat exchanger. The molten salt heated by hot helium in the intermediate heat exchanger transfers to the hot molten salt tank. The hot molten salt exchanges its heat with feed water through the superheater, evaporator, and economizer. After the heat exchange, the cold molten salt is sent back to the intermediate heat exchanger for recirculation through the cold molten salt tank. The cold helium is recirculated to the reactor by the circulator after heat exchange with molten salt in the intermediate heat exchanger. The feed water becomes hot steam as it passes through the economizer, evaporator, and superheater. Hot steam rotates the turbine, and the kinetic energy generates electrical energy in the generator. Hyundai Engineering and USNC will successfully complete MMR plant demonstration at Chalk River and construct the MMR plants worldwide where clean energy is needed. We are preparing for the exciting start of micro-modular reactor that will lead the future energy market with convenience and high efficiency beyond cleanliness and safety.
Thank you. Okay, can you see
Yes.
this
Yeah,
slide?
you can see the slide.
Yeah. Through the videos, I think explain about the MMR project is enough. So skip. Yeah. I would like to explain about the MMR pure cycle from this slide. So already you saw the MMR pure, TRISO, and FCM pure product, something like that. So FCM means the polyceramic micro encapsulate pure in the production. So yeah, I will explain this and the figure. This figure about a kind of a procedure, the MMR pure from the TRISO. And from TRISO, this is we call the pellet. Some the TRISO. This is a kind of in the cylindrical, the small cylindrical, and the pellet inside the cylindrical. So many TRISO in there. Also, in material of pellet is a silicon carbide. Normal other HTGR vendor using and graphite as a material of a pellet. However, USNC and developed from since 2011, 2010, using the silicon carbide for the make and the pellet. We call the FCM, polyceramic micro encapsulate pure. The USNC have a patent about the this kind of technology. This is a graphite block because there are so many holes in graphite block. Some hole is a pellet in there, some hole and pass over the helium as a coolant. This is a graphite block. This is a reactor core. Reactor core consists of so many and graphite block, and this is a nuclear reactor in the plant. And yeah, this procedure about the manufacture the TRISO, Bicol and the Sol Gel module, and some procedure conversion module, particle coating module, cell formation module, some, and I think next time, so the expert and the manufacturer fuel can and explain in more detail. And yeah, this procedure already and the TRISO, and in the this is silicon carbide substructure. You can see and so many and the TRISO in pellet silicon carbide structure. This is like this. This kind of structure is made by 3D printing. It means the very and the very complicated, very the accurate structures. So everything is the same because of using the 3D printing, something like that. So also pure densification, and this is FCM pure. Also, USNC has a pilot pure manufacture facility in the US. This pilot the pure facility has all procedure of manufacture FCM pure, also the graphite pure. And there is two pilot manufacture facility. One is in Oak Ridge. Oak Ridge can and manufacture the FCM. One is Salt Lake. Salt Lake can make and the graphite block. And in future, the same place, in the same place, and the two technology will be and together. And also USNC has a plan to the commercial type and pure manufacturing facility is now in the finding, and there is two possible the site, and the capacity of production rate is about 20 megaton. The enrichment less than 10%, and the supply of pure, the supply of UO2 in Urenco, and the total the area is 189 and 1,000 square feet, and some already USNC made the contract with this kind of pure manufacture with the Pramatom in the US, the Pramatom the area in the US. Yeah, this is a general pure cycle from the front end and the back end, and like and the mining area, some and the milling and the conversion and on enrichment and the pure fabrication, also burning pure in the nuclear power plant. After burning nuclear power plant, there nuclear power plant produced spent pure storage, spent pure. In the case spent pure, the two-way, one is reprocessing, the other is the disposal. I can explain in detail. In the back end, some after about the spent pure storage, so one is a disposal, the other is reprocessing. Disposal, there is a two-way for disposal temporary. One is wet storage pool. Normally, this kind of wet storage pool located in the nuclear power plant. And the other is a dry storage facility. Okay, in Korea, this kind of the pure cycle facility already in Korea, the had this kind of pure cycle facility. Okay, in more detail. Some, yeah, and you metal mining, open pit mining, underground mining, in situ mining, some, and from the original uranium mining, we can make a yellow cake, U3O8, some U3O8. The your concentration ranging from more than 8% using. I'm not sure this way. And at that time, natural the UF6 and enrichment and UF6 to the 3.4%. This type of enrichment uranium is used for and commercial light rod reactor, the Hichi, and already built in the worldwide, and the reconversion process, your pellet process, and your assembly process. This is a normal nuclear fuel of a light water reactor. After that, about the spent fuel storage, already, and you know this, and Finland is the first country which has and disposal facility of spent fuel, some the first country, and the specification of this facility is the area is about 2 square kilometer, capacity 3,500 ton, and multi-layer disposal system, and this is a schematic diagram of spent fuel storage in the disposal system. And after that, this is another way of reprocessing facility. Some I think there is a 5 and 3 country which can and make reprocessing of spent fuel. Is a kind of we call the proliferation the strategy of IAEA. I think US and UK and France, also more China, Japan, Russia. I think this country can the reprocess. Okay, next. Yes, some, and this slide showed about the spent fuel of high temperature gas cooled reactor and the storage status, and the US, and you know the US, in US several HTGR was constructed and operates now in the decommissioning. That is the beach bottom, the post brain, and the pure type of this plant is thorium uranium carbide pure in graphite matrix in the triso. The triso means the three layer of three layer outside of uranium. Biso means the 2 layer. And the type of disposal, dry storage in Idaho National Laboratory. This figure showed the dry storage in Idaho National Laboratory of high temperature gas cooled reactor spent fuel. And the United Kingdom, type of high temperature type of gas cooled reactor different, quite different from the US. And we call the GCR, gas cooled reactor, using carbon dioxide. And also this kind of plant using and graphite block as a moderator. So pure type is UO2 pellets take into the stainless steel, ground together the graphite, and the disposal, and the type is the wet disposal in the, and spend the pure put into the pool underground. So, and after some time, go to the final disposal, we call the geological disposal facility. And from this slide about the radioactive waste management, and this figure showed the classification of IAEA radioactive management, like and exception waste, and very short-lived waste, very low-level waste, low-level waste, intermediate waste, high-level waste. I think most countries follow this kind of classification of radioactive waste. In Korea, okay. In Korea also three type of in Korea has three type of radioactive waste, and depend on the type of radioactive waste and the disposal method is different. I can explain the next slide. Yeah. Also, this slide showed about the radio waste type from the plant. There is a three kind of radio waste. One is gas, and the liquid, and solid. In the gas, through some and the treatment, and I think the pure gas, filtered gas. I mean not the contaminated gas is into the atmosphere. Also, and the environment radiation detect in there. And the liquid radioactive waste, some treatment, some pure contaminate water into the drain to the environment. Some contaminate the water waste through some treatment into the radio waste disposal facility. Also, solid the can follow the similar procedure. So in Korea there is some procedure about the receiving and storage facility in the radioactive waste. We call the center. And the transport container, the drum disposal. There is some procedure like waste management, visual inspection, the surface contamination measurement, compressive strength test, nuclide analyzation, X-ray inspection, also repacking. But this is a disposal container. Is a capacity of 6 drum, the size like this. Also, and this type of the container will be located in the radioactive waste place in the near surface and the land meter, something like that. Yeah, this slide showed in Korea radioactive waste the place, and we call the radioactive waste center, radio facility located in the east south area. The total area is approximately 2.1 million square meter. disposal capacity and 800 sound drum. There are three kind of phasure, three kind of disposal type. We call the first phase, second phase, and the third phase. I can explain the next slide. In the first phase, we call the rock carbon disposal place. It's a kind of the carbon disposal place. So in the constructive tunnel, operation tunnel, the waste loading tunnel, and also some disposal, the silo. And the second phase is a kind of surface facility, not the underground. And the third phase, I think, is near surface in the place. So this kind of all radioactive waste disposal place, just one area in Korea. Yeah. Also, and regarding to graphite, you know, this graphite is I think only radio waste coming from the high temperature gas cooled reactor. In the US, in case reactor, the hand point, beach button, post brain, also the break heaven research center, and the disposal type of DOE means the Department of Energy, low level waste disposal facility in the Nevada, like this. And also United Kingdom has graphite radioactive waste, the reactor, such as Berkeley, Henderson, Sellafield, some this kind of reactor can produce the graphite radioactive waste. The method of disposal is the geological disposal facility we call GDF in England. I think this facility not finished for construction. I think this is planned like this. Yeah, in Korea also there is a small radioactive graphite. This is radioactive graphite from coming from the Trigger Mark 1 and 2 research reactor. I think this is the first research reactor in Korea. Some in the transport to the Daejeon in the Korea Atomic Energy Research Institute. In the CARI, we call CARI, there is some place for storing this kind of radio waste material. And in future, just temporary, in future, we call the Gyeongju radioactive waste center. Also in Japan, from the boiling water reactor, there is some graphite red waste. In Japan, and some graphite red waste and removal and some treatment, and finally transport to the disposal area. Okay, I think this is a final the slide. This is just the plan because because MMR is not built yet. So this is I expect I have to make a plan about the radioactive management for MMR. In MMR, from the MMR, there is several kind of radio waste like low level, very low level, in the waste management, also graphite, also spent fuel. In case of spent fuel, some and in the intermediate stage, dry storage police facility. After that, the deep geological disposal. In Korea, there is no deep geological proposal facility. However, Korea government now plan to build this kind of facility in Korea side. Also in the graphite, also in the low level lead waste in the temporary storage in on-site, and after that some treatment, and I think some treatment and more than and intermediate level. In this case, go to the geological facility. Also, and less than intermediate level and the disposal near surface place, near surface facility, and like this. Thank you very much.
Thank you, Mr. Lee. Thank you very much for your presentations. And congratulations on the achievement of your MMR project at the Chalk River. Ladies and gentlemen, now we are open for questions from Mr. Lee, questions and discussions. I see some questions in the chat room from Mr. Gagat Rahmadi, but before that, I would like to invite Mr. Saiful Bakri, our director at the Research Center, to give your first comment and remarks.
Okay.
Silakan, Pak.
Okay. So yeah, okay.
Thank you, Mr. Lee, for a very good and very comprehensive presentation. I think it covers everything of fuel cycle. But before continue with the question and answer, Bujo, perhaps I would like to little bit shows to Mr. Lee what is our current research, if it's okay.
Okay.
And then talk about BRIN. I believe perhaps Mr. Lee would like to knows better what is BRIN and what is the research center inside the BRIN, which has the responsibility for nuclear development, for fuel cycle, or for other nuclear technology research and development. So, yeah, I will try to present for 5 or 10 minutes. Is that okay?
Yeah, no problem.
Okay, yes.
Yeah, thank you, Mr. Lee.
Yeah, that's very good. Yeah, silakan, Pak.
Yeah, ladies and gentlemen, especially for Mr. Lee. Yes, again, I would like to introduce my name as well as my research center here. Actually, it's not my research center. That's BRIN's research center. Yeah, the name of center is the Research Organization, Research Center for Nuclear Fuel Cycle and Radioactive Waste Technology here. And we are under the National Research and Innovation Agency, especially on the Research Organization for Nuclear Energy. I'll try to talk a little bit about the BRIN's organization. Hopefully it can give you a quite clear view what is our position right now here in the BRIN's and what is the research organization. You can see here on the right side, we have 16 research organizations. It covers from nuclear engineering until here, for example, Research Organization for Electronics and Informations. And we are here is the executing agency. And we have another 1, 2, 3, 4, 5, 6, 7 deputy, for example, here, deputy for development policy, deputy for research and innovation policy. Both deputies deal with the policy here in the BRIN, whatever the policy in terms of research and development, public policy, for example, sort of like that. And deputy for human resources, deputy for research, innovation, infrastructure, special for the infrastructure here, all research reactor, fuel facility, for example, waste facility, they are under this deputy for research, innovation, infrastructure. And deputy facilitation for research and innovations, basically this deputy is funding, deputy funding agency, funding units, or division inside the BRINs, and deputy for utilization, research, innovation, and deputy for research and for regional research and innovations. And this little bit information about each task of the deputy, I'll try to skip these ones. I've already mentioned briefly each task of deputy. For example, the duty of research and innovation policy deal with the research and innovations, and especially for the policy, and the duty for research infrastructure here to really deliver, to really maintain our research facility as well as laboratory inside the bridge. And these are the research center inside the nuclear energy research organizations. We have 7 research center right now: Research Center for Nuclear Reactor Technology, Research Center for Research Center for Nuclear Fuel Cycle and Radioactive Waste Technology, and other research center, for example, Radiation Detection Nuclear Analysis Technology, Radiation Process Technology, Research Center for Safety, Metrology, and Nuclear Quality Technology, and Research Center for Accelerator, Radioisotope, Pharmaceutical, and Biodosimetry Technology. Basically, for the research center, which is quite close with the nuclear power plant or energy fuel cycle, sort of like that, it's only 2 research center here: the Center for Nuclear Reactor and Research Center for Nuclear Fuel Cycle and Radioactive Waste Technology. And other research center, yes, we have an interface with them in terms of energy, for example, in terms of how to prepare the detector, in terms of how to make sure the safety, the quality of our research and project, for example. Yes, another research center have an interface and collaboration with other with these 2 research centers in the top. And again, I would like to highlight what is the nuclear position right now in terms of net zero emissions. In 2049, it is expected that about 5 until 7 gigawatt at that time it will be nuclear here, Cummins, and at 2060 about 35 gigawatts. It means that before 2049 we need about 8 or 9 years to really prepare the first nuclear power plants. Let's say, for example, 10 years, yes, we need to start the first nuclear power plant at least at 2030, let's say, sort of like that. And since at that times, the nuclear will be the base load, I think, to really help the solar or other renewable energy resources. And the challenge is how to prepare 5 until 7 gigawatt by 2049 and 35 gigawatt by 2060. And we are not really sure what type of nuclear power plant, what type of fuel cycle that time should be prepared. But this is the time right now, I think, to really consider, to really think what is the future of Indonesia, what is the future of technology of nuclear power plant in Indonesia. And what's the best capacity for nuclear reactor in Indonesia on the large population area here, Sumatra and Java, probably could be the large scale of nuclear power plants. And this small area here on the left side, the east region of Indonesia could be the SMR. But it can be another scenario. For example, if we have a super grid sort of like that, which connected one and another islands, it could be the renewable energy on the left, on the west side of Indonesia can be supported with the large nuclear power plant on the left side, or vice versa. Or, for example, on the other side, we can also deploy the small modular reactor on the left side, which can be used to really as a base load for the renewable energy on the Sumatra or Java Islands. And where's the nuclear power plant potential site? This already researched by Batan at that time, and now it's continued with BRINS. So, for example, Muria, Banten, Bangka Islands, it's Kalimantan, West Kalimantan, Batam, and Nusa Tenggara. We have several potential sites here. The current site is about in West Kalimantan. And what is the stand of nuclear power plant? Yes, we are a research organization. We are open basically to all type of reactor and all technology right now. But yes, we need to a little bit try to focus our research, and based on our direction from our chairman, that we are requested to really consider the SMR or the generation 4 of nuclear power plant, including the fuel cycle of this supported nuclear power plant. And what is the research and development position right now in BRIN? Research and development right now in BRIN is mandated to overcome right now drastically low critical mass of research resources in Indonesia, to improve research, to attract young talents right now, to conduct the research, support global engagement, and enable government, for example, as a facilitator for business player, for example, like you right now, like Hyundai or other international vendor, for example, to conduct the research based on product and development. And then we have a strategy by integrating research and innovation here, such as human resources, infrastructure, budget, and resources, and creating an open or inclusive and collaborative global standard research ecosystem right now in BRINS with industry, for national industry as well as international industry, creating a foundation of strong and sustainable research and innovation-based economy. And based on these three strategies, our implementations is first will build a strong human resources and on nuclear energy, and then the secondly as this technical support organization and nuclear reactor and fuel technology co-developer. Why? Because BRINS, why co-developer? Perhaps audience you also try to raise a question sort of like that. Why we can be a co-developer? Yes, because as long as the plans, the nuclear power plant is still, let's say, until demo plan here, from the research development, creating prototype, and then put the pilot or demo plan, BRIN has mandated to be part of co-developer or license holder. Yeah, but if the reactor has been commercialized or already commercial or already commercial somewhere, have a design certification sort of like that, and will be deployed in Indonesia, and our position can be the technical support organization for the commercial. And about the research and development of our of NPP and also fuel cycle right now in Indonesia, our research center is the only one research center in Indonesia deal with the nuclear fuel cycle. We tackle from the front end until back end. From the front end, how to prepare nuclear fuel, mining, conversion, enrichment. But we are not deal with the enrichment actually, and fuel fabrications as well. And we also have a reactor right now, research reactor in Indonesia, and we also study the reactor design and operations. And for the back end, we deal also how to reprocess, and safely manage, prepare, and dispose radioactive waste and spent fuel from our own research reactor as well as from other facility, for example, hospital or industries. And we also research how to really, let's say, knows what is the uranium, and thorium deposit in Indonesia. We do research, for example, here from 1969 until 2019, from the geological mapping, geochemical, geophysical. We do sort of drilling and also chemical, petrographic, and mineralographic analysis here using our laboratory in several areas, for example, Kalimantan, Sumatra, and Java. And this the research facility in our research center. This research facility is fuel research facility in our research center. Basically, we have fuel element production here for research reactor. We have 3 research reactors, but the biggest one, 30 megawatts, is produced by our research by BRIN. I mean, sorry, by Inuki with the man or human resources from our research center. And we have experimental fuel element installation for power reactor in Serpong and HTR fuel fabrication technology research facility also in Serpong. And we have another 2 here, for example, research reactor to really understand what's the characterization of our fuel for our fuel experiments. We tested in our test facility of GASUMC 30 megawatt multi-purpose reactor MTR, and we have a post-radiation test facility as well in building 20 Serpong area. Talk about the research of HTGR. Yes, we have several research right now, and we still conduct this research from 2017, if I'm not mistaken. And we have several kernel from zirconium here, for example. And this is the example of our simple fuel kernel research facilities. And this is another research as well from 2018 to 2021. We produced zirconium precursor, and then we have surface morphology in 2020. We have also research on how to determine sphericity control here. And in 2022, we plan to have a serious stabilized zirconia research here with our facility in building 62 in Serpong area. This is our fluid research in Indonesia right now. This is been published in IAEA Advances in Small Modular Reactor Technology Development booklets in 2022. This one of the achievement of our researcher right now in Indonesia. The name is fluid. It stands for Pembangkit Listrik Uap Panas Industri Indonesia. That means for nuclear power plant for cogeneration electricity and industrial heats. And previously we have also RDE, this experimental power reactor. That's 10 megawatt electric thermal. And the type HTGR, the location actually in the Serpong area. This is the prehistory from the RDE. We started the research from 2015 until 2016. We transferred the conceptual design from Lucum, Germany, and then developed based on this conceptual design to be our basic designs. And we have a funding from the Kanada DP. We got the funding at that time from 2018 until 2019. And we developed design at that time, but it's not yet finished because another policy at that time. And this is the facility we've got experiments and simulation of HTGR from the cryogenic facility to purify the coolant to remove the krypton, xenon, sort of like that. And this is the RCCS, reactor core cooling system. Sorry, we developed, and this is the simulator for the HTGR. And we also researched the radioactive waste management for not only for HTGR but for our research reactor, and also the future perhaps. How to really prepare a long-term disposal in this area. We also determined several long-term disposal area for the first nuclear power plant in the future. Yes, that's all. I think just a little bit information for, especially for Mr. Lee. What is our research? What is our achievement so far in terms of HTGR, and what is our role for nuclear power plant development? And by the same thing, little bit information about our organization. We hope that we have a common ground so we can move forward with, let's say, for example, what kind of research specific can be done together, or what kind of technology can bring supported for the future. If, for example, Hyundai will try to deploy the first example of MMR, the first example of HDR in Indonesia. So our government will not reluctant with this kind of technology. We will be confident that yes, we have every researchers here back you. We have researchers here understand what kind of technology, because we develop this technology together, because we try to evaluate, assess, to support you in terms of regulation, for example, together. So this technology comfortable for our people, comfortable for our governments, and ready to be deployed easily in Indonesia. For example, 1, 2 in East Indonesia, for example, or West Indonesia, with the support also based on industry or electricity company. We have several electricity company right now attend our discussions. Yes. Okay, Bujo, that's a little bit response from me. Actually, I'm not respond Mr. Lee presentation, but try to give another perspective for Mr. Lee. Hopefully, we get more understanding each other. Yeah, thank you so much.
Thank
Thank
you.
you so much. Thank you so much, Pops.
So I have one comment.
Yes, please. Yes, please.
Yeah. I am very impressive about the status in Indonesia, the research, the history and experience about high temperature gas cooled reactors. I'm very impressive. Yeah. So, and you know, these regarding to Chalk River demonstration the project. This project in future will be and finished in the 2026 we expect. So however, so nowadays and many university like Illinois University and the McMaster University in Canada also, and the Finland University, and want to collaboration with the USNC Hyundai about the MMR. You know, the before the 2026 and MMR, the complete demonstration and the validation verification. That's why many universities interested in the collaboration about the deployment MMR in their university for research, also on the training and something like that. So I think recently the Finland University, I don't remember exact name. So also Finland University have a MOU with the USNC about the MMR as a research reactor deployment in their university. I think so next time, so about the face-to-face meeting, so how to make close collaboration for this kind of technology, high temperature gas cooled technology. So Indonesia, also Canada, also the USNC. You know, this Caddy also have many experience about high temperature gas cooled reactor, about the pure and the manufacture, the price pure, some safety analysis, the code, also design technology. So we can discuss more detail about how to and collaboration and develop this kind of technology. Thank you.
Thank you, Mr. Lee. That's very
thank you, Mr. Lee,
positive,
for your
yes.
kindness.
That's very positive. And you also mentioned education, and that is very important because GREEN also promotes building capacity, training, and also pursuing a higher degree, master and doctoral degree. Yeah, Pak Saiful?
Yeah, very good, very good.
Yes.
Yeah.
So.
Yeah, exactly, Bujo. Correct.
Yeah. Also, you know, these and now I am and Hyundai Engineering, also other Korea company, also including Caddy. We prepared the project about high temperature electrolysis using MMR technology. We call the SOC technology. So I think the SOC high temperature electrolysis the device we call the solid SOC, solid and oxide electrolysis cell, something like that. This is not commercialized. This is development stage. So I think using MMR high temperature steam, some Hyundai Engineering, also other companies wanted to develop and hydrogen production technology. So I think that this is a very important point, and the collaboration between the Korea partner and the Indonesia partner. Thank you.
Okay, I need some clarification. So before 2026, can anyone outside party, those who have signed MOU, take a look, visit the project in Chalk River? I mean, is it open, or is it like after 2026? I mean, during this construction project, can anybody, or can we actually visit, or?
Yeah, no problem. Yeah, open. So also, also, my understanding about your question is you can visit and the pure manufacturing in the US. Also, you can visit and the Chalk River site in the parking lot, just parking lot. And I think next year we can get the permission for site preparation licensing. At that time we can start site preparation. Now is just the parking lot. The parking lot. This is potential. The site of MMR post project is parking lot of Chalk River laboratory. It means the Canadian nuclear laboratory, mean the Chalk River laboratory. It's just a parking lot nearby and main building.
Okay, so we should follow the progress.
Yeah.
Yeah.
Also, I can send about the progress. You know, this university project. Also, you know, this McMaster and Illinois, and starting to the project for the licensing procedure, something like that.
Yes. Okay.
Yeah,
The licensing.
For only for research and the test in university.
Okay.
However, same technology.
Yes.
Between the research reactor and the commercial reactor, same technology.
Okay. And you also mentioned about codes. Yes, codes. That's Kairi. Kairi has the codes, or Hyundai Engineering.
Yeah, we have collaboration. Also, Kairi, now participated in the MMR project. Is Kairi and developed all kind of safety analysis computer code, the core design and the safety analysis computer code. So, and the USNC use this kind of computer simulation code developed by Kairi for MMR project.
Okay. All right. That's very good, Saiful. That's something to follow. For your information, we have over 90 participants here today, and some of them come from the Ministry of Energy and Mineral Resources, also from the state utility, also from the Pertamina oil company, who is also interested in nuclear reactors now, and I think some of our colleagues from the regulatory agency are also here. I see Mr. Asin Sidki in the participants list. Mr. Asin Sidki, I know you typed the questions in the chat column. If you like to ask Mr. Lee directly, you can do it now. Mr. Asin Sidki.
Okay, thank you, Mr. Lee. This is interesting presentation of your material. it is power plant suitable for energy transition in Indonesia because you know that we need more hydrogen and ammonia green. This can produce by MMR like your presentation. So I asking you about what it's mean 20 years lifetime. It is just only all for refueling or system of your MMR. Thank you.
Yeah. Now we are demonstration the project of MMR has a lifetime of 20 years. Because we can extend lifetime design lifetime some, however, and originally the MMR developed by request from North Canadian territory for mining and the remote village. So, and they want and the design lifetime 20 years for MMR. So we can extend and the design life to the 40 and 50.
Okay, for refueling period, how many months or years each?
Excuse me, pardon me.
For refueling, it means a change of fuel periodically.
Yeah. Theoretically, if you are using HALEU means is nearly 20%. It's no refueling, just no refueling during the 20 years. However, nowadays HALEU nuclear fuel issue because most of HALEU nuclear fuel come from the Russia. You know, the Russia war Ukraine. That's why, and the Western country and do not want to use HALEU uranium fuel for Russia. That's why, and recently, and HEC and USNC and changed is not HALEU, we are LEU plus 10% enrichment uranium. In that case, and 10 years. So after 10 years, we replace the core one time, just one time.
Okay, thank you. It is clear for me.
Thank you.
Okay, thank you so much, Pak Asin Sidki. So, okay, so the LEU plus 10% that would last for 10 years?
Yeah, the 10%, 10 years.
Yes, and then you
20%
the
is 20% is 20 years.
20 years.
Yeah.
But after 10 years, you have to replace the core?
Yeah, core.
Okay, so if you have, if the plant will have like a 40, 50 years, you have to change the core several times.
I think this is a developing stage now, and the U.S. government is starting to build HALEU nuclear fuel manufactured in the U.S. So I think, and 5 or 6 years later, we can use 20% HALEU uranium. In the case, and in the case of during the 20 years, we don't need a replacement nuclear fuel of MMR.
Okay.
It's a kind of intermediate stage.
Okay, thank you so much. Next, I would like to go to the questions in the chat column, but maybe Mr. Lee, you can also see the questions there.
I can read from top.
Yes.
Yeah, okay.
So the first question from Mr. Gagat Rahmadi, what is the biggest difference, I think, between your fuel compared to the conventional prismatic fuel in HTR? From and also from the economic point of view. Yes, go ahead.
Yeah, so you know the normal HTGR use, you know, these pellet type. this is pellet consists of a triso, also and the graphite structure. Using is a pellet, you mean is the cylindrical structure is made by and graphite. However, and the USNC and developed is a cylindrical structure by silicon carbide. Silicon carbide, a kind of ceramic, like a stone, very and strong, very strong material. It's mean the more and safety margin for melting temperature and something like that. You know, the graphite also is a good material. However, the graphite is I think more have a more weak, and some touches, some frictioning, something like that. So that's why the USNC and choose as a material for silicon cylindrical material as a silicon carbide. The only company, using the silicon carbide as a material of the pellet structure material.
Okay. Second question, the drawback of using the carbon due to its large force and the possibility for cracking of the microspheres. This is quite technical, actually.
So,
yes. If you have any comment, otherwise we will also we will provide you these questions so you can ask your field experts and get back to us.
Yeah, you know, I think graphite is very good material for as a moderator, as a structural material for the nuclear. So, you know, there's so many and the nuclear power plant using the graphite as a the moderator. So also some technology of graphite is much improved than, and also Chernobyl using the graphite moderator. However, and nowadays and the technology of graphite is more improvement, more advanced nowadays. So there are so many test data for the graphite and the material, the properties, something like that. So I can provide the graphite material for answer for question.
Okay. And also, I think the third question, talking about the dispersion agent that you use. In the fuel production in your.
The carbon question?
Yeah, the carbon question. That's very hydrophobic, and what sort of dispersion agent that you use in the fuel production? I think.
Yeah. Already I told you there is some carbon black is a kind of graphite. The carbon, I think a carbon black graphite and some people say that this kind of and the graphite, the weakness graphite drop back some. I think and the US, UK, also Korea and Japan, some and the scientists, researchers, and developed the technology for overcome this kind of problem. So I can and send the material about this question about the graphite material, graphite, and the test data, something like that.
Okay. All right. Thank you.
This is very technical. I don't know exact answer. I'm sorry.
There's another question, our curiosity. This is from Miss Ratih Langenati. She texted me, what is the length of the structural material, your silicon carbide? What is the length of the
cylindrical
structure? Yes, the
Uh,
FCM, the cylindrical structural material, the silicon carbide, the cylinder. What is the length? How small is it?
I think is and the length is length less than and 3 meter, 3 cm.
3 centimeters.
30 centimeter, and the diameter is a kind of 2 centimeter.
2 centimeters.
Yeah, very small cylindrical shape.
Okay.
So
Okay.
also I can
Send the
and
information.
FCM pure the information.
Okay. And also what is it? How much is used for one fuel load? How much uranium you put in one load?
So I don't know exact exact quantity of some. I also send and pure loading data. Okay.
Okay. All right. Thank you. So next we move to the question from Ms. Heru Sriwahyuni. How much, this is also technical, how much activity, mass, and volume produced per year for low level and very low level waste?
It's mean the and MMR case.
Yes.
Yeah. So this. I think we have to we have to calculate this kind of because MMR now is not the construction. So also we have data. Some and also those questions I will and send the material for you.
Okay. Thank
MMR,
you.
it's a kind of MMR plant radioactive.
Yes.
Data, something like that. Okay.
Yes. Okay. There's another question from Mr. Winter Dewariyatna. This goes back to the capital cost of the reactor MMR and how long it takes to build.
Yeah, it's a capital cost that depend on the project specific, like site location, also the country, something like that. So I think the post plant is more cheaper than the commercialized plant because the post plant need and licensing lot of licensing work. Also some and the supply chain is not fixed. That's why I think more the expensive than and the commercial reactor. So what the capital cost the MMR, I think through the feasibility study between the HEC or the Indonesia, BRIN, Indonesia and organizations, we can find the capital cost MMR in Indonesia.
Okay.
Because it depends on the labor cost or something like that. Yeah.
Okay.
I think after commercialized, so I think the MMR is a kind of nuclear battery. And the PWR large water reactor has a very huge concrete structure, something like that. It's not the modularization. However, MMR is a modularization. So now we developed is a kind of a model, not 5, 10, 20, 30. We are going to develop several kind of MMR model. So in the case, and the capital cost MMR, the much lower than and the post MMR project in the Choco River.
Okay.
Also, it's a construction period less than the 6 months.
Oh, construction period is less than 6 months.
6 months, yeah. The very
that you expect for commercial.
No. It's still in the some the current, because you know this.
Current.
Yeah, you can see MMR. MMR structured through the video.
Mhm.
Yeah, the current MMR design, designed by module.
Okay.
Yeah, module, two type of modules. So, and in factory can manufacture the module. However, inside just connecting between the module, not the construction. We call it installation the job. That's why. And after site preparation, I can say, and the construction period less than 6 months.
6 months. Okay. Okay. So maybe the regulation takes longer, licensing and so on.
Yeah.
Yeah. Okay.
Because MMR and the original purpose of MMR is will be constructed in the northern area of the Canada. Is northern area of Canada is the climate is not good. Yeah, the period of day and above 0 degrees C is less than 5 months, something like that. So that's why we developed this kind of the design using the module.
Yeah, and you also have the cooling tower, the MMR.
Yeah, the cooling tower. So you don't need the water for cooling.
Yes. Is there any plan for transportable type? Because this is a land-based, I suppose.
Some question?
This is, I think this is a land-based reactor. Do you plan to have like a transportable type that you can move around in water? I mean, just transportable, like the Russian KLT-40.
I'm not sure. Yeah, I am the HEC in US focused on
floating, sorry. The float,
focused on the current reactor. You know.
Okay.
Yeah.
Okay.
After that demonstrations, we can develop the other type, floating type. Also, I think very important that the floating type MMR, because and produce the ammonia, hydrogen in the ship.
Okay.
So I think it is a very important item. However, in future.
Okay. Okay. Mr. Winter has a second question. Is the plant performance affected by graphite block swelling?
Yeah, still I provide material about graphite
Later. Yes.
Okay.
Talking about the cost of the plant, we are also interested in the cost of the fuel fabrication. Do you have any information on the economics of the pilot plant or the actual plant, commercial plant that you're going to build Yes. Do you have any information on the cost?
About what
the economic of the fuel fabrication?
Fuel fabrication cost?
Yes. Yes. The cost. Yes.
Yeah. You know pure. You know the HEC and the USNC wanted to build and the pure fabrication factory in US now. So it means the post nuclear fuel, MMR nuclear fuel, the more expensive than and the commercialized some, you know. So I think this kind of question related to a kind of the capex, you know. Yeah, capex including EPC or pure cost, something like that. So we can discuss later. Also with the material, we can discuss this question.
Hello. Yes, Mr. Lee.
Okay.
Oh, okay. Okay. I think my internet connection was disrupted just now.
Okay. So yeah, we are Kelly.
Yes.
No, we do not use carry facility like post validation examination. So and MMR nuclear fuel already finished the test using and facility in the U.S. national laboratory like Idaho laboratory, Oak Ridge laboratory. So
Okay.
yeah, we do not use carry facility.
Okay, so that answers question from Mr. Antonio Gogo. The next one from Mr. Subar Bagiono is ease of decommissioning also a consideration in the reactor design? When you construct something, you must have a decommissioning plan. So
Yeah. We are going to make a decommissioning plan for the licensing. It is a very small reactor. So also, this TRISO. Even if accident case, TRISO can protect and radioactive material outside the TRISO. That's why its contamination area is very small. That's why it's very easy decommissioning. So now we are the plan to decommissioning.
okay, so you have taken that into account as well.
Yeah. Also, we consider design of plant and the decommissioning plan, something like that.
Oh, okay. Yes, that's another business that is flourishing.
Yeah. But it's same question about the volume of waste generation. I will send you the information about the waste information of MMR.
Okay, yes. So that's question from Mr. Hendra Adi Pratama. Yes, he asked about the volume of waste generated, the ratio, and so on. His last question is there a roadmap or timeline for the development of MMR and the need for disposal facilities? Because you mentioned about the waste management, do you plan to have a roadmap or timeline?
Yeah, I think is already timeline for MMR developed already. I told you.
Yes.
So, yeah, I told you in the first project.
What about the waste?
Waste, this. I think regarding to waste treatment, it depends on the site area, site country. It's now and the first project in Canada. The Canada has good infrastructure for nuclear the waste management. The Canada has and the 20 nuclear power plant in their countries also has infrastructure for treatment of nuclear radioactive material, something like that. Also the spent fuel. However, each country situation is different. Each country is different. Already we are consider design of MMR, including some radioactive material, some the treatment system in the MMR plant, like and the packing and some the solid, liquid, air, radioactive material. We have a design. We have a system already, including a system for treatment this kind of radioactive material in MMR design. However, after the decommissioning, so how to treat this kind of radioactive material. This question depends on the country, each country in specific situation, infrastructure, something like that. I think.
Yeah. Okay, that reminds me, in your presentation, you haven't mentioned Canada, their waste management policy, and what is your agreement, I think, with the Chalk River on the management of the waste? Is it going to be stored there temporarily, and whether the spent fuel or the waste will go into the Canadian waste management facilities?
Yeah, is there the Canadian Radioactive Waste Management Organization. I mean the NWRD, something like that. So yeah, also USNC or the CNL will make a contract with this kind of the organization. You know, it's a Canadian policy. It's all Canadian, and the policy I think is that this kind of organization can treat disposal, something like that, all kind of radioactive material. You know, So we in the doing the operation of the MMR, we are the temporary storage in MMR plant. After that, the radioactive material move to this kind of storage facility. This is a Canadian case.
Okay, for the Canadian case.
Also, I think is also Indonesia have to will make this kind of some procedure, law, this kind of organization which can and the treatment store radioactive material, something like that.
Okay.
Yeah.
Okay. I got a message from Mr. Antonio Gogo. I think I missed his question. He asked about the collaboration on post-irradiation examination with KAIRI. Is it also possible?
IP?
Yeah, Antonio Gogo, he also asked if we can be informed about post-irradiation techniques. You will send information, I think.
I think it's regarding MMR project, there is no relationship. And PIE facility of CARI. However, you know this CARI has a PIE facility. So I think and the CARI and the BRIN has many time the meeting have also some collaboration for nuclear the research and development, something like that. No?
Okay. Yes.
Yes. In the case also, I have many plans in the CARI, so I can ask CARI to provide the PIE information.
Okay.
Okay.
Okay. Yes. I hope it's okay, Pak Antonio Gogo, because he texted me. Not sure if the question.
Okay.
Okay. Yeah. Okay. Thank you. Last question in the chat. What is the minimum capacity of particle coating module for the manufacture of TRISO? I think this is also very technical. Maybe you can include it in your reply information, I think.
Yeah, also this is a very specific cost of fuel. So I will send this kind of, and somebody some store so memorize this kind of question to me.
Yes, we already copied the questions and then we will send it to you.
Thank you,
Mr. Chow.
Thank you very much.
We thank you very much.
Based on the question, I will send more information to you.
Yes, okay, thank you. I don't see any questions in the chat. Maybe Pak Jarod, if you have questions.
Okay.
Yeah, silakan Pak Jarod.
Well, Dr. Lee, thank you very much for your presentation. It's very impressive one and answer all of my questions before. First, when we talk about the development of new technology, well, I can say this is a new technology. You also consider the fuel manufacturing. You saw us that Ultra Safe Nuclear Corporation also developed the pilot nuclear fuel facilities. And correct me if I'm wrong. After this Chalk River project, if you want to develop other projects, it seems to me that you will cooperate with like a Framatome, as you mentioned in your presentation, to fabricate the fuel. Is it correct?
Yeah.
Or your pilot nuclear facility will be also developed as a fabrication plant for the future.
Yeah, already pilot pure fabrication, the finished the construction.
Oh, okay.
Yeah, finish the construction. Also, they
Just-
now they can produce the TRISO and the FCM.
Just for pilot or for maybe for the future?
No.
Scale up?
This is pilot is just one a kind of one, and we call the one batch, one module.
Okay.
One module, some including all the procedure, all process for manufacture TRISO, FCM, something like that.
Mhm.
Yeah, some
Okay.
some, and however in the commercial case need more module,
Mhm.
a kind of
Okay.
10 module, 20 module, something like that. Now in the pilot and the pure facility, and now and produce the TRISO and FCM pure for test.
Mhm.
Yeah, something like that. So if you visit and the US Oak Ridge facility, you can see, and the TRISO very similar, the gel type
Mhm.
TRISO and also the FCM pure.
Okay, thank you. And the second comment is when we developed, Pak Saiful already mentioned about the polluted or experimental power reactor RDE HTGR project in the past. The Australian government asked us about the safeguard of the HTGR fuel. And well, of course, we answer and response. We will follow what the international regulation but as far as I know, there is a safeguard by design for this HTGR technology. What do you think about that on the safeguard? Because this is very important when we have to convince the neighboring countries in Indonesia if we want to develop HTGR.
Yes, you mean the a kind of export control or something like that? Yeah.
Not only export control, but how to count the uranium, the fuel, and to convince that this fuel is not to use for example, nuclear weapons or something like that, for the safeguard.
Yeah. So I think I gonna check some. First, this IAEA protocol, additional the protocol. I think Indonesia already make some contract, make some and agreement, additional protocol with the IAEA. That's right.
Okay. Well, yeah. I think later on I will ask you later technically about this.
Some
yes.
Also I gonna check in the US government the policy. So well, as an action item, I gonna check some the US and the US technology. This is MMR including the US government technology.
Okay.
Yeah. So that's why I some and the USNC the export and the MMR in Indonesia is possible or not, something like that.
Okay.
Okay.
Pujo, can I have another question?
Yes.
No
please.
problem. No problem. Yeah.
Okay.
Yeah.
You talk very good things about the graphite radioactive waste. This is very important things because so many people ask me during our project, HTGR project, how do you handle the graphite waste? And you saw us many some countries with their management of graphite waste, UK, US, Japan, and Korea also. But it seems very interesting to me that Korea will not dispose but recycle the radioactive waste, the graphite waste. Is there any reason, or if you know about the reason why the Koreans doesn't want to dispose or to build the disposal facility for this graphite radioactive waste?
I think wait a minute, just not. I think the graphite, the quantity of graphite from the Korea nuclear facility is very small.
Okay,
You know, very
from
small.
the trigger. Okay.
Yeah, trigger is a very small.
Yeah.
It's a, you know, also the radioactive material of graphite is not high. It's a kind of a low level. I think a low level, and low level of the waste, maybe some low level waste, maybe some. In the case of some, we also we have in Korea has and the radioactive storage place, some, and the graphite we can, and the graphite radio material transport to the that place.
Okay.
Yeah.
Okay.
Some I heard you know the UK has many the radioactive graphite because you know UK most UK plant is a gas cooled reactor. So I heard UK research some after some treatment graphite and reused also, and the level of radioactivity make more lower. Some is a kind of and the low level, very low level. Regarding to the low level, very low level radio material is storage, dispatch is very easy, you know, very easy. I visit a US radioactivity facility just ground, put the ground, and after that the peel with some soil, something like that. That's it. And that's why. Well, I ask why. Why did you radioactive material so easy treatment and very low level radio material? Then no problem. There is no impact on the environment and the people who nearby live.
Okay. Thank you very much.
You are welcome.
Thank you.
Yeah,
Terima
thank
kasih,
you, Pak Jaran. Thank you. One quick question, just curiosity. Why are there two pilot fuel fabrication? One in Oak Ridge and one in Salt Lake.
Salt Lake is the graphite manufacturer.
The graphite.
Yeah, graphite. So yeah, in future, same place in Oak Ridge. Okay. Yeah, current Oak Ridge facility in only for triso efficient fuel. However, the USNC now and construct and graphite manufacture in the same place.
Okay.
Yeah.
All right. Okay. Thank you so much, Mr. Lee. I think from the question and answer, we can close the discussion. And I think Mr. Saiful Bakri and Pak Jarod will follow up with you on the remaining questions and to get information from you. Thank you so much. Thank you all participants for your for providing the questions. I will give back the time and space to Miss Ai. Silakan Bu Ai.
Thank you. Okay, we have come to the end of the event today, and thank you so much again for your participation. Also, thank you to Mr. Saiful Bahri, Ms. Johanna Maria, and special thanks to Mr. Lee Sang-il from Hyundai Engineering for sharing your knowledge and experience. We hope our collaboration can be further in the future. Terima kasih. Kamsahamnida.
Thank you. Thank you very much.
Thank you, Dr. Lee.
So
Thank you very much.
Thank you.
Thank you, everyone.
Bye.
Thank you.
Okay,
Thank you, Dr. Lee.
Yeah, thank you. So please send me material presented by and
Mr. Saiful Bakri.
Yeah, Saiful.
Okay.
Yeah. Thank you very much.
Yeah, thank
Okay,
you.
thank you.
Also,
Goodbye.
questionist.
Yeah,
Oh
of
yeah,
course.
yeah. I will send it to you.
Yeah.
Okay, thank you.
Yeah. Thank you.
Thank you.
Okay,
Thank you very
you.
much.
Bye. Stay
Bye-bye.
safe. Thank you.
Bye.
Bye.
Bye.